Hey, it's Mr. K doing a video for AP Physics C Mechanics, and we are looking at a little bit of calculus, mainly derivatives and some other options besides the power rule for doing derivatives or taking derivatives. And we're doing the power rule. Just to start off, we're going to do the product rule, then something called the quotient rule when you have things being divided, and then we're going to finish it off with the chain rule. And let's go ahead and start back up here with the power rule. Just remind us what we're doing. When you take a derivative, you are finding the slope or equation of slope for a function. And so remember, for a constant, let's say -3, that slope would be nothing. It would be 0. And so whenever we do find a derivative, we're going to write it as the dy over dx. X's are the things that we're using here as variables. And so it's like a small change in whatever this function is divided by a small change in whatever we're plugging in. And so that would be a slope. So looking at the power rule, you can split it up into these three segments where you have additions and subtractions kind of splitting up your equation. So we can just look at 5x squared first and use the power rule. Power rule would take the power, drop it down in front, and multiply the first number, and then do -1 to the power. So I'm going to have 2 times 5, which is 10x. 2 minus 1 is going to be 1, so that's just going to be 10x. 2x is next. 2x, the power would be 1, drop it in front, it's still 2. X now to the 1 minus 1 would be 0, so I'm just going to have 2. And then the derivative of a constant is just 0, so I'm just going to leave that off. So just a small reminder of how to do the power rule. The product rule is whenever you have two functions multiplying each other and you want to find the derivative of this whole thing. So we have a function here, we have a function there within this main function, y. And so really the trick would be either to FOIL this out, which we can do. We can say, okay, the first we get 6x squared outers minus 6x inners plus 2x, and then we can do lasts, which is going to be -2, and then we can say, all right, we've got 6x squared minus 4x minus 2 as our, sorry, as off the page there, as our expanded function. And then if you wanted to, we can say dy over dx to find a first derivative would be to take the power of 2, drop it down in front. 6 times 2 is 12x, minus 4x becomes 4, and of course that -2 would drop off. So the first derivative would be 12x minus 4. Instead of expanding it out, you could use what's called the power rule. And the power rule would be where you would define one function and another one. And so we're going to call A 3x plus 1, and we're going to call B 2x minus 2. So we essentially have function A multiplied by function B. And the trick to the power rule is whenever you want to find the derivative of whatever this is, you would take the derivative of 1, let's say the derivative of A, and just multiply it by whatever B was. And then you're going to add it to the derivative of B and multiply it by whatever A was. And that should be the, I'm not sure why I'm going back and forth between cursive and print, but you're going to take the derivative there, and it's going to be the sum of those two. So, let's put it into practice. A prime, so 3x plus 1 is going to be A. The derivative of 3x plus 1 is just going to be 3. And we're going to multiply that by B. B was 2x minus 2. All right? We're going to add that to A, which was 3x plus 1. And then we're going to multiply that by the derivative of B, which is going to be 2x minus 2. That's going to be 2. Okay, and so let's go ahead and just distribute these. We're going to get 3 times 2, it's going to be 6x, minus 3 times 2 again is going to be 6, plus 2 times 3, that's going to be 6x, plus 2. And so if I look, I can put these 6 x's together, I have 12x, and -6 and 2 is going to be -4, and I get exactly what I got over here when I expanded it. So the product rule is just going to shortcut you expanding everything, by, watch out, by a little bit. There's another rule called the quotient rule. Whenever you have a function dividing another function and you want to find a derivative of that, again, we're going to say this is actually like A divided by B. So function A is 3x plus 1, function B is going to be 2x minus 2. And there's a little moniker that you would say, which would be low d high minus high d low over low squared. So the low function here, low d high, would be B. And d high means that we're going to take the derivative of A, so A prime, minus high, A, up here, d low, the derivative of the low thing, B prime, divided by low squared, so b squared. Okay, and that would be how we would find the first derivative of whatever this is over here. So going back again, we're just going to plug stuff in. We're going to put b. b would be 2x minus 2. We're going to take the derivative of a, which was just 3, multiply those two together, minus a, 3x minus 1, or plus 1, and then b prime is going to be 2x minus 2, that's going to be 2 right there. Divide all that by b squared, and b squared would be, well, I'm just going to put 2x minus 2, and we're going to square that. Okay. If you want to, you can expand this all out. Not sure of a really good way to do this one and kind of make it into some final solution, but after you've expanded this all, actually let's just do it. We got on the top 3 times 2x is going to be 6x, 3 times negative 2 is going to be negative 6. I've got a minus 2 times 3x, which is going to be minus 6x. We've got a minus 2 times 1, which is going to be a minus 2. And so, okay, so that goes away, that goes away. I have negative 6 minus 2, which is going to be negative 8. There we go. On the bottom, we're going to have 2x minus 2, and we're going to square all that. So I could just say, oh, let's just do 2x minus 2. And let's expand that out if you want to FOIL that out, or if you remember just how to do it. That's fine. Let's just FOIL it out. Firsts, and this is going to be on the bottom. The first is going to be 2x times 2x, 4x squared. Outers, minus 4x. Inners, minus 4x. Lasts, plus 4. So in total, we're going to have a first derivative using the quotient rule of negative 8 on top divided by 4x squared minus 8x plus 4. And this would be the first derivative of the function y here, where you have one function dividing another. Lastly, we're going to talk about the chain rule. The chain rule is whenever you have a function kind of nested within a function. And so it kind of looks like you can use power rule, and you can if you actually expanded this out. So remember that this to the third power there is actually like saying 3 times 2x squared times 2x squared times 2x squared. Okay? And that's totally fair. You can go through this and say, all right, we've got 2 times 2 times 2, 2, 4, and 4 times 2 is 8. 8 times 3 is going to be 24. 24, and then we have 1, 2, 3, 4, 5, 6. So x to the 6th. All right. So hopefully, if we use this thing called the chain rule correctly, we're going to get something that's like 24x to the 6th, and we can take the derivative of this. I'm going to be lazy, and we're going to say 6 times 24 gives me 144. So y prime here should be 144 x to the 5th. Okay, hopefully we get that. And so let's look at this thing called the chain rule. The chain rule is going to help us kind of get by doing all this stuff. And so if we take the chain rule, what we're going to say is we're going to make this function, let's call it a. 2x squared is going to be a. And we're going to change it. We're just going to say this is 3a to the 3rd. Okay? And the chain rule will say that when you have a function that's nested within another function, what you're going to do is you're going to take the derivative of the outside function, so whatever this is, and we're actually going to multiply it by the derivative of the inside function. Okay? And so let's show you how to do that right now. So 3a to the 3rd, the derivative of this would be, take the 3 down, that would be 9a to the 2nd. But then what we're going to do is we're actually going to take the derivative of a, and we're going to multiply by it. So the derivative of a prime, would be, a being 2x to the 2nd, that would be 4x. And so all we're going to do here is just take the derivative of the outside function, 3a to the 3rd, that becomes 9a to the 2nd, and then we're going to multiply by the inside function that's nested inside, which is going to be, the derivative of that would be 4x. So my answer here should be 9a originally was 2x to the 2nd, times a prime, which is 4x. Okay? What we were allowed to do now, because this should be y prime, the first derivative, is we can double check. Is this 144? And so to do that, I'm going to say, all right, 2x to the second, we have 9 times 2x to the second is going to be 4x to the fourth. And then we have that multiplied by a 4x again. So this is actually going to be 4x to the fifth, but I already kind of wrote it down with pen, so I'll just put a 4x out here. We're going to have x to the fifth. I've got 9 times 4 times 4. 9 times 4 times 4 gives us 144. Alright, so that matches up right there. So the chain rule is a way to do this. If you have nested functions together, you can either try to expand them out, or you just kind of use the chain rule and take the derivative of the outside function, keeping the inside the same, and then multiply by the derivative of the inside function. What's kind of neat about this, you're really not going to see this too much in physics in this scenario, but where you will see it is whenever we start to talk about things that do this, which are things that are repetitive. So imagine like a pendulum swinging back and forth, back and forth, back and forth. If this were a function of position over time, what you can look at is the slope of position. Say this is position versus time. When you look at the slope of the position time graph, we know that to be velocity. So if you look, where the positions are maximum, the velocity is a minimum. Where the positions are in the middle at equilibrium, our velocity, the slope, is the maximum. And so what functions would we use to describe this? And the answer would be like sine and cosine. Sine and cosine repeat. And sine and cosine happen to be pretty much perfect opposites of each other whenever we talk about the position and the velocity. And we can even go on to talk about the acceleration. So if you want to talk about sine of some angle theta, if we wanted to find, let's say this is y. If you wanted to find the first derivative, y prime, then that would actually be, turns out, cosine of theta. It's kind of neat. If you wanted to do y double prime, the second derivative, cosine would turn back into sine, but you'd stick a negative in front of it. Okay. If you want to take the y triple prime, you would still have the negative, sine would turn back into cosine. And if you wanted to do the fourth derivative, y bop, 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 it would be cosine goes to negative sine, it would go back to sine again. Okay? Now each and every time you do this, if theta is just constant, great. If it's just theta, that's fine too. But really, whenever you take the derivative, if let's say we had like sine of, or let's say 3 sine of 2x, let's say that. If that was my function y, if I wanted to find the y prime, the first derivative of this, I've kind of got a function within a function, right? So it's kind of like I have like 3, the sine of something in there that we can call a. And so when we want to find the derivative of this, we're going to take the derivative, probably shouldn't have written that yet, of the outside function, which is 3 sine. So 3 sine would turn to 3 cosine of a, which was 2x. And we're going to multiply that by whatever the derivative of a is, or whatever the derivative of 2x is, which would happen to be just 2. So my y prime would be equal to 6 the cosine of 2x. And so that's how you would do the chain rule with a nested function like sine or cosine. All right, I'm going to end that here, double check things, and we will wrap this up.